Jason Roberts, and in this video I'll be explaining the process of how titanium nitride, or tin, is made. From raw titanium ore all the way to the shiny gold coating we see on cutting tools, medical instruments, and aerospace components. Nitride properties. Let's start with a quick look at some properties of the ceramic. Titanium nitride has the formula tin, or titanium 3 nitride. It's an advanced ceramic compound, extremely hard between 1800 and 2500 HB, and has a metallic gold color with a smooth reflective finish. Like most ceramics, it's chemically stable, wear resistant, and highly corrosive resistant. But unlike typical ceramics, it also conducts heat and electricity moderately well. It's biocompatible and dense, about 5.2 grams per cubic centimeter, making it ideal for both functional and decorative uses. Nitride itself isn't mined. Instead, it's made from titanium ores such as rutile, TiO2, and aluminate, FeTiO3. There are three main ways to extract titanium ore: open pit mining, which is from the surface deposits; underground mining, from deeper layers; and dredge mining, where floating dredges collect heavy titanium minerals from sand. Once used one of the three methods, the ore is transported to processing plants for further refinement. Crushing. The first processing step is crushing. Titanium-bearing rocks are crushed into fine particles, freeing the titanium minerals from the surrounding material and preparing them for concentration. In this image, you can see the titanium-bearing rocks being crushed in the crushing chamber, which frees most of the titanium particles from the rest of the material. Concentration. Next comes concentration, where the titanium-rich particles are separated from waste rock using gravity, magnetic, or flotation methods. This increases the amount of titanium dioxide, TiO2, in the sample, producing a purified concentrate ready for chemical treatment. And in this specific diagram, we have magnetic separation, which is the finely ground ore being used on a conveyor belt, which is magnetic, which separates the magnetic particles, which in this case is the titanium di dioxide, and then the rest of the waste particles from the remaining of the ore. Processing, chemical treatment. In this step, the concentrate is heated with carbon and chlorine gas to form titanium tetrachloride, or TiCl4, a liquid that is easy to purify. The chemical reaction is TiO2 plus T2Cl2 plus C goes to TiCl4 plus CO2, this is your titanium dioxide plus your chlorine plus your carbon, gets you titanium tetrachloride and your carbonate as your byproduct, excess product. This process removes impurities like iron and sets up the pathway to obtain pure titanium metal. Refining. The Kroll process is used to refine titanium. Titanium tetrachloride is reduced with molten magnesium in a sealed furnace to produce pure titanium metal, and a magnesium chloride as a byproduct. The purified titanium is what will later convert into the ceramic compound titanium nitride, and in this diagram we can see the Kroll process in action, which is your electric furnace, your magnesium chloride, and it's your recovery port, your TI sponges, your magnesium, and your steel reaction container, which contains the entire process. And where here is your titanium tetrachloride being inserted and your magnesium inserted. Overall, this is just the Kroll process of this step. Preparing. The pure titanium metal is formed into targets or pieces using in the coating systems. These pieces are cleaned and placed into a vacuum chamber where nitrogen gas will later be introduced to help form the titanium ceramic coating. And in this one, we use an arc evaporation vacuum chamber, where your gas inlet, which is your nitrogen gas, gets fed into the system. Here's your vacuum pump, which will be used later. Your rotary, which spins the whole chamber. Your power supply, which powers it. Your heaters are here and here. Your substrates, or tool components, are along this line. The entire thing is your vacuum chamber. Your plasma is on here, specifically the gray rectangles. Your arc source is the yellow square you see within the middle, and the target material is right where the yellow thing is. Processing. Vaporization. Next, the titanium is vaporized using heat or plasma energy inside a physical vapor deposition, or a PVD chamber. The titanium vapor spreads throughout the chamber while the surface to be coated is preheated to ensure strong bonding of the ceramic layer. And in this diagram, you see the pump, gate valve, your magnet, your target material, which is your titanium composite, and your water, your clamp rings, your pedestals, and so forth. Overall, this is what your PVD chamber would look like on a schematic form. Processing, reaction and coating formation. In the PVD chamber, the titanium vapor reacts with nitrogen gas to form titanium nitride molecules. These ceramic molecules bond tightly to the surface, creating a thin 2 to 5 micrometer layer of gold-covered coating. This ceramic coating is what gives cutting tools and implants their exponential hardness and corrosion resistance. And in this diagram, you can specifically see the coating that's being formed. This is the material you're putting your coating on top of, which in this case is FeNiCrMO. Here's your tin or titanium nitride, and then a little bit of gold on the very top, which gives it the look of titanium nitride on its tools and components. Cooling and finishing. After coating, the parts are cooled gradually to prevent cracks. Then the surfaces are polished or given additional ceramic layers for smoothness and durability. The finished result is a dense, hard gold-colored ceramic coating that is as functional as it is visually striking. Here's an example of a finished product. Here is a diagram of the process of taking titanium ore into titanium nitride, which is you start with your ore that is mined using the 3 mining methods previously mentioned, then is taken into a crusher that crushes the ore, then it's concentrated to concentrate into TiO2, which is then chemically treated with TiO2 plus carbon and chlorine gas, which is heated to form Ti tetrachloride, which is reduced to make pure titanium, and then propellant, which is basically cleaning the titanium, vaporization, which is your vaporized titanium, and then it's reduced reaction slash coating forming, which forms your titanium nitride, which cools into your settled titanium nitride or your finished product on the material surface. Of titanium nitride is your machining parts, your medical tools, and components of semiconductors, specifically the yellow pins you can see in this semiconductor. Titanium nitride is a ceramic material formed when titanium reacts with nitrogen gas. Its creation involves multiple steps from mining titanium ore to refining, vaporizing, and finally forming a ceramic coating. This thin yet extremely hard ceramic layer enhances both protection and appearance in countless engineering and consumer applications. The citations.